So today we have second talk, second webinar. Will be delivered by Nazri. All right, he's one of our a member in my PCS. Okay, without further ado, I would like to invite Nazri to give his talk. Okay, Nazri, to you.
Okay, Assalamualaikum and very good afternoon. First of all, I just want to ask whether you can see my screen that I am sharing right now. Can anyone now see the screen that I'm sharing?
Yes.
Okay, good. So, okay, my name is, as Fauzi introduced already, my name is Muhammad Nazri bin Fuad. Currently, I'm doing my PhD under supervision of Prof. Madya Dr. Noliza at UKM. My current research is something got to do with advanced process control for cell culture bioreactor. So this is just to fulfill the request from from Dr. Noliza to share something that I know about Python programming. Since my PhD project, I do a lot of programming using Python. Actually, before this, I used Matlab a lot, but once I discovered about Python, so I already transitioned towards Python programming. Now I'm not using Matlab a lot anymore, only in some cases to do certain calculation where they are required to use Matlab, because maybe in case where there's no library or package available for the Python in some rare situation. So the purpose of this presentation is just to give a gentle introduction to Python for Matlab users. But first of all, I want to know, have you able to access the slide? I think I share with Mr. Fauzi this slide and some CSV files that I hope going to use during this session. Because
Nazri, I haven't upload the material yet. Okay, for those who want to get the material, I will put in our Facebook and I will.
I think better you try to get the material, because I try to make this session as hands-on as possible rather than me talking and you all listening. So better if you all can also not somehow participate, not 100% participate, but at least somehow you also can try all the stuff that I'm talking about here inside your own machine. So the main thing that I want to stress is, if you can install Python, first of all, I want to know how many of you already have some experience doing Python programming. May I know how many of you already have some experience in doing Python programming? So for those of you who already have experience, I want to know which do you use any kind of special distribution Python, like any special distribution of Python, or you install Python from the website itself? For those of you who have experience doing Python programming before,
have
any of you using any kind of special Python distribution?
I use Conda.
Conda, yeah. Conda is one of the distribution that I also want to emphasize in this, because it's one of the friendly distribution for those who want to start doing Python programming. It support for individual edition. You can download just for free. So I hope that today also if possible, I want also all of you can install at least this Anaconda distribution in your machine, so that at least you have something to have after this seminar. Okay, so if you have opened your browser, so you can try to go to this website, anaconda.com website. There you can download the individual edition installer, because the reason we use Python distribution is that so that all the distribution or the libraries that we need for our application is already provided. Because Anaconda is one of the popular distribution for scientific and engineering computing. So meaning that once you download this Anaconda into your system, you already have all the package that you need almost all the package that you need to jumpstart your scientific or engineering programming in Python. So if you have, if you can, then I think you can try to Google this website, Anaconda website, Anaconda Python website, and try to download the installer that's provided there. The individual edition is free, meaning that you can install it and use it without any issue about whether you have to pay or not, because it's free. Only for the enterprise edition, you have to subscribe to their service. So basically, the Anaconda is one of the popular Python distribution for scientific programming. As you can see, this is the example of the Anaconda front-end interface. Once you download it and you install it in your computer, so once you open it, this is the screen that will greet you. As you can see in the screen, that they show you several of the IDE package that you can use it out of the box. So this is one of the advantage of using the Anaconda distribution, so that you can jumpstart your Python programming without any concern about whether you want to find the package that suit your need or not. Because if you want to go for the manual installation, you need to install all the packages that you need manually by yourself. The package that I'm talking about, like example, numerical library package, scientific library package. But if you straight away download this Anaconda distribution package, you at the basic, you already have all the package for scientific and application that you need. You have the numerical package represented by NumPy. You have scientific package represented by SciPy, or you can also get the machine learning package represented by scikit-learn. So it's best if you can try to download and try to install this Anaconda distribution in your machine. Okay, so this is one of the optional. Before you start any Python project, it's good practice if you can create an isolated virtual environment for your particular project. This one is a good practice to avoid any model dependency issues. What I mean by isolated virtual environment, okay, in this case, I'm going to show you the example. Okay, so here I'm going to open my Anaconda distribution. Okay, this is my Anaconda distribution. As you can see, currently the application is on the base root environment. But somehow, if you want to start any particular Python project, it's best if you can create your own isolated environment, so that you can ensure that all the modules that you need will not clash with the module that is provided in the root installation directory. One of the easier way to create this environment is by going to this environment option. So in this case, as you can see in my current installation, I have several isolated environment, where each of this isolated environment is based on the project that I am currently doing. So like I said, it's best if you can create, before you start any Python project, you can create your own isolated environment, and you install all the package that you need in that particular environment. So for example, I want to create a new environment for the webinar class. Okay, so in this case, I create the new environment. I call it my environment webinar, just to show example. And then I can choose whatever Python version that I need. Okay, currently you can see in my screen, the latest Python version is 3.8. This is one among the latest Python version. But let's say that your project requires you to use certain library that is only available in Python, in older Python, for example. Maybe that library is only available in Python 2.0. Okay, right now Python is already in the third version, but in the third version. But if your project requires you to use certain library that is only available in the Python 2.0 environment, so this is the point of creating this new environment. So in this case, if you want to create a new environment that requires you to choose a specific Python version, so this is how you can do it. You create a virtual environment, an isolated environment, and you choose whatever Python version that you need. So in this case, once you do that, then you can install all the library dependencies that requires that particular Python version. So you can see once I create my new environment, so in this case, the Python itself will fetch whatever basic packages that will be installed in this isolated environment. So in this case, this environment will be isolated. All the module dependency is only installed in this particular folder only. So if you don't have any kind of conflicting dependency issues with other module that you install in the root directory or in the other Python environment. So this is good practice if you want to start your Python project. You try to create your new environment just to avoid any issues that regarding the module dependency. And then after you create your virtual environment, then you can populate with your required packages, modules, or libraries that you need in your particular project. Okay, now my environment is webinar and I've already activated it, and you can see the current installation package is already listed here. So if you want to find additional package, okay, then you can try to search package. For example, if you want to install a numerical Python in this particular environment, I can just try to search it, and then I can install it. So this numerical Python will be installed in this environment only. It will not disrupt the root environment or other environment that I've created specific for certain project that I'm currently doing. So this one of the advantage of using the Anaconda distribution is that they already prepare all these things for you in the very friendly user graphical interface. Okay, that's it. It's about the part of the preparation of UPC for Python. And then another issue that we need to take care is if you want to do programming in Python, it's best if you can do it in the integrated development environment. Integrated development environment is where environment that you can do your coding and also that you can run your Python script inside the same environment. So there are several types of integrated development environment for Python. We have PyCharm, PyDev, and one of my suggestion, if you want to start do your Python programming, if you want to start your Python programming journey, is to use this integrated development environment that we call as SPIDER. SPIDER is a short form for scientific Python development environment. This one is a great IDE choice for scientific programming. Because why? One of the advantage is that, okay, this is the example of the SPIDER IDE, SPIDER Integrated Development Environment. As you can see, the way they lay out this IDE is have some kind of Matlab feeling to it. Okay, you can see it looks like it looks almost like in Matlab, where you have the console where you can run your command, and then you have a window where you can program your script, and you have also a variable explorer window for any variable that you created in your console. Then that variable will be show up in your variable explorer. So in this case, you can check during your calculation, when you do your calculation, when your variable is created, then you can check the value of your variable. You can use it to validate whether your work or your calculation is doing correctly or not. So this is one of the popular integrated development environment for scientific programming using Python. So this spider is provided as default whenever you install Anaconda distribution. To access this spider environment, so in this case, I'm going back to my base root environment, base root installation. So you can see if you already install your Anaconda distribution and you open your Anaconda navigator, you can see that spider is already provided. Is already provided for you. It's already installed as part of the default installation of your Anaconda distribution. And then you can just click the button launch and you can straight away launch your Spider IDE and you can start doing your work, your coding and any of the stuff, okay? Any of your Python stuff. So this one is about the integrated development environment. So okay, so one of the things that you need to be aware about Python is that unlike programming language like C++ or Visual Basic, the Python is not a declarative programming language, meaning that the variable that you want to use, you don't have to declare. You only need to initialize it during your coding and calculation. This one, if you programming in Matlab, you're already familiar about this concept. Okay? But there are several data structures in Python that you need to have certain kind of declaration first. And this data structure, in fact, this data structure is unique to Python itself. We have, for example, here I present an example of unique data structure in Python, list, tuple, and dictionary, where for this case, I'm going to focus on the list data structure in Python. So to see example of how you want to declare your list, how you want to create your list and you populate your list object. So this is the example of the list usage, of list declaration and usage. So in this case, if you already install your Spider, then you can run this command in your Spider console. For example, if I want to run this command in my Spider console, I just open my Spider. Okay, let me start my Spider kernel. Okay, so in this case, I'm going to show you how you can run this command in your Spider console like you do in your Matlab, where you run your command in your Matlab console. So for example, here we're going to create a list and populate it with this element. Okay, so here I just can create the name of my list and I can just populate it with the element that I want to populate in my list. And you can see in Python, the list is quite flexible, meaning that you can store whatever data in your list. So for example, here you can see my list, I populate it with strings and also numbers of floating point number and also integers. So you can see. That's how you create and initialize your list. Then once you finish, then you can press enter. Now you can see one of the advantages of using Spider IDE. Once you create your variable, your data structure, then it will automatically populate it in your variable explorer window. So you can check your command execution to make sure that you do everything correctly. So now in this case, I create an example of how you can initialize your list and populate it with any element that you want. So here also I show you about the printing function. This printing function is a unit of Python. For example, if you want to print the element of your list, then you can just use the print function. Although in console, sometimes you don't need to use the print function. You can just type the name of your variable, of your data variable, and it will automatically show it for you. But it's just to show you the function of the print function, which is quite common, okay, when you do programming in Python. So in this case, I use the print function to print the element of my list. I can see it will print all the element of my list that I defined previously. And also I can use the print function to print a certain element that I access using the certain index. For example, I want to print the element in my list that is stored at index number 1. In this case, I just I use the print function, the name of my list, and I supply the index where I want to access that particular element, meaning the element that is stored at index number 1. And see, so in this case, you can see the index number 1, if you see in my list, is represented by this string that have the word omega. So now you can see, unlike Matlab, in Python, every index must begin with index 0. Unlike Matlab, every index start with number 1, but in Python, they follow with all the conventional programming language. The first index of your element of your array, list, or any collection object is start with index 0. So for example, if I want to print the first element of my list, so I need to supply that index 0. So it will print the first element of my list. So this is one of the things that we need to watch out whenever you do programming in Python or any programming language, because they use the starting index 0. So in this case, okay, this is the example of accessing the element of the list and you print it. And also you can override the existing element in your list. For example, I want to override the element that I stored at index number 1. Currently, the index number 1 is stored this string of the word omega. But now I want to override it. I want to, I want to store a new variable, a new value, which is 1.212. So in this case, I just assign that value to my list at that particular index. Okay, so in this case, I type my list 1 equals to 1.212, and then, so now you can see if you print my list, then it will show you a new element, a new list where the old element that at the index number 1 is overwritten by the new value that I specified here. So this is the example of application of list usage in Python. Another things that you need to aware when using Python is unlike Matlab, when you use Matlab, if you want to use certain package, you don't have to import it. You only need to provide the search path in your Matlab file search path, and you can just use the library or package straight away. But in Python, before you can use any of package or libraries, you need to first import it so that that module, the code in that module will be available to be used. So the import keyword, you can see the 3 example of import keyword here. So in this case, for example, the first example, if I want to import the math library, so this is how I run the command in my Python console, in my Spider console. Just type the import keyword, and then I type whatever library that I want to import. This is another example. This one, I want to import the numerical Python library, the NumPy library, and I want to give a different alias to it. So in this case, you can see import NumPy as NP. This is how I give a new alias to my module that I import. So now, instead of using NumPy, I can use the short form NP in order to access any codings inside that library, inside that particular module. And then this is another example of how do you import a library in your Python environment. Example, this is the same example. I want to import the NumPy library, and I want to use the roots function. Where the roots function is they want to find the quadratic roots of this polynomial that is defined by this coefficient. So in this case, that function roots is provided as part of the NumPy installation. So this is how I access that roots function inside the NumPy module library. So this is how you import your module before you can use in your Python programming. So in this case, so it's good to be aware what type of library that is currently that you can use. Okay? What is the basic numerical and scientific libraries that you can use? So you have NumPy. NumPy is one of the basic libraries for the numerical for multi-dimensional array manipulation. It can support multi-dimensional array. You can support the vector operation, matrix operation. The another library is SciPy library. SciPy stands for Scientific Python Library. This one, this library is more heavy set. It have library for ODE solver, ordinary differential equation solver. They have library for optimization solver. You have library for signal processing. So if you want to do, if your work involves some kind of library that using optimization, signal processing, or numerical ODE solution, then you can use this SciPy library. Another library that is famous for data science is Pandas library. This one is for the data manipulations. Okay, you want to import data in Python and you want to manipulate your data. Okay, so this is one of the library that you can use, Pandas library. And another library that's famous for the machine learning, for basic machine learning, is the scikit-learn library. Scikit-learn library is one of the basic library for machine learning that you have straight out of the box conventional machine learning packages such as linear regression, tree regression, neural network. So this is one of the libraries that you can use for conventional machine learning usage. So in this case, I want to show, for example, how you can use the numerical computations. You want to, how you can use your Python for the numerical computations. So for example, this one is to show a common problem. You want to find the linear algebra solution problem. Let's say you want to solve linear algebra. You have three unknowns in three equations. And here is the demonstration of how you can solve this problem by using the numerical Python library, the NumPy library. So in this case, you can see the example. This is the demonstration of how you can do the matrix manipulation, the vector manipulation. So, for example, here is problem. One of the way that you can solve this problem is you express this in the matrix symbolism. For example, from this coefficient of this equation, you can take away all the coefficient in your matrix A, okay, and then the unknown in your matrix X, the vector X, vector of unknowns, and this is the vector of your forcing function, the right-hand side of the equation. And now you can use the NumPy library to solve this particular problem. So here you can show you of how you first import your NumPy library. So so this also show you how you create a matrix data structure using the NumPy library. As you can see, before you can create the matrix A to store your coefficient matrix here, you need to have a way to represent this value first. So you can see here, I define the coefficients for my matrix A using list. As you can see, this is an example of list within the list. You can see in my master list here, I have three elements. Element number 1, element number 2, and element number 3. And each element is also a list. They have three values. For example, in the element number 1 of this here is also a list that have three values, represent the row coefficient of my matrix A here. And this one is another list that have the second row coefficient of my matrix A. And the third list here is the list that stores the final row coefficient of my matrix A. So you can see this is an example of list within the list. So this will become my input when I want to create a matrix A that I'm going to use when I want to solve this equation. Okay, and then for the vector of coefficient, vector of the right hand side here, so I just create a list and I populate it with 3 elements that correspond to the values of the coefficient of my right hand side of the equation. Sorry. Okay, now once I created this list, then I can use this list to create my matrix. To create my matrix, I need to use the array function command in my NumPy library. So in this case, once I imported by my NumPy library and I give my lsmp, so in this case, I want to create my matrix A, then I call the function array, I supply the value, the variable list that I created here. So this to create list, I create the list and then I supply the input to this array function to create my matrix A. And then same for the vector V, vector of the right hand side coefficient. So in this case, I use the array function in my NumPy library. I give the list of the right hand side coefficient. So for this list, I also call another function, another sub-function, another sub-module, where I'm going to reshape it into a vector where I have 3 rows and 1 column. Because if I don't use this reshape function, then my B vector is just a normal array that don't have any particular structure to it. So in order to make sure that my vector, the right hand side vector is really correspond to this column vector, so I call the reshape command and I give the first word, the first argument is 3, meaning that this is column vector, there are 3 rows and 1 column. So once I created my matrix A and the vector B, then I can call another submodule within my NumPy library, where I'm going to invert my matrix A, because the solution requires the inversion of this matrix A and do the matrix multiplication with my vector B. I'm sorry, I didn't put the formula here, but basically it requires you to find the inverse of your matrix of coefficient bus and times with your vector coefficient of your right hand side. So this is how you execute. So this part is where you find the inverse of your matrix A. You call the inverse function, INV function, within the linear algebra package, within the NumPy library package. So you can see there are 3 dots here. The more dots, meaning the more depth that you go into the library itself in order to find this inverse function, the metric inverse function. So once I do this calculation, then my solution will be stored in my X vector, where when I print it, it will show you the result of this operation, which represent the unknowns in my equation. So in this case, the first unknown, the X is represented by 5. The second unknown Y is represented by 3. And the third unknown Z is represented by -2. So this is example of Python for numerical computations. So in this case, if you able to set up your Anaconda distribution and you can open your Spider, and once you download this slide that I think is already provided in the Facebook page, in the My Control Society Facebook page, then you can try this on your own. You can try to practice this on your own just to get a feel of how you do the programming in Python. Okay, one of the functionalities that we're always looking when you do the engineering competition and then scientific competition is how to plot your result. So in terms of graph plotting, also there are several libraries that you can use. One of the common library that you will see from time to time, if you go Google it, for example, if you Google Python plotting, you will encounter this library, Matplotlib library. This is one of the earliest library and quite common library what people use when they want to plot the result in the Python. And another library is Plotly library. This one is another alternative library that you can use also for your graph plotting. And another library also PyQt-Graph. This one is one library that you can do for fast plotting. If your program requires update your graph in real time, then you can opt for this library, PyQt-Graph library. So this is an example of how you plot, of how you do your plotting inside your Python. When you do your Python programming and you want to plot your result, it's for this example. So again, you can see in this example, I use NumPy library and I also use the PyPlot library within my Matplotlib library. And then this PyPlot library, I give the alias PLT. So in this case, before I use whatever package inside the library, then I have to import it. And then, so in this case, I create the time using my NumPy library. I think you are familiar with this function. It's like a linspace function in Matlab where you want to create a vector of value from start to finish. The start is from 0 to 10 and separated by 0.1 interval. So this is how you do in the Matlab, in the Python, sorry. And then, so this one, I create the time array, the array of time from 0 to 10, where the space between each element is 0.1. And then I calculate the amplitude. So in this case, I use the sine command because I want to create a sine wave. So in this case, the sine function is already provided as part of NumPy distribution. So I just call the function and I input this time vector that I just created to generate the amplitude values. So now I can call the plot function within this PyPlot library that I give the alias as PLT. So this is how I plot the graph, give the X value and the Y value. And then this is how I give the title and then the label for my X-axis and the label for my Y-axis. So the result of the plot will look like this. So this is an example of plotting, of how you want to run a plotting tool inside your Python. And this you can run, all this you can run using the Spider IDE. That's one of the advantage of using Spider IDE. Okay, so this is an example, all this example that I showed just now, all these examples you executed in your Python console window, in your Spider IDE console window. This console window. Alternatively, you can group all these commands in your script. For example, if you want to create a script that run all your command, so that instead of running the command one by one, why not just create a one file script and then just run the file script so that all the commands can be executed automatically, autonomously. So this is the purpose of Matlab scripting. So I think this Matlab scripting also you're familiar with and like the M file script in Matlab. So for example, here I want to create a script where I can run my plotting command. So in this case, I just copy and paste every command that I put here, and then I put inside a script file. So for Python script file, the ending is .py as .py ending, .py extension. So, and you can see in this script file also you can do comment. For comment, you have to use this, what symbol is this? The hash symbol for the comment. All this is for the commenting. This will not be executed by the Python interpreter, just to give a sense of documentation of your coding. And so once you create your script, you can save your script in a certain folder, and you can run script. Either you run it through the command line window. In the command line window, you can type Python and start the name of your file. Or if you hate doing command line interface, you can use the Spider run file utility, where you can find this run file utility here. If you open your Spider, you can find there's a button that looks like a play button, and there's pop-up here say run file. So once you create your script, then you can make sure that your script file is open, and then you can just click run file to run your script file. And the Spider will use the run file utility to run your script. Oh, sorry, this is not Matlab script. This is not Matlab script. This should be Python script. There's a typo error here. Okay. And then, so once you go into the Matlab scripting, sometimes when you do your scripting programming, sometimes you need to control the flow of your execution of your program. So like in Matlab programming also, you need to familiar with the application of if statement, while statement, looping statement. So of course Python that is designed as a general purpose programming language also definitely will have all these utilities to control the flow execution of your program, of your script. So this is the example of the control flow statement in Python. The if statement, the while statement, as you can guess, the if statement is to control the if else, to control the conditional branching of your program. While statement is when you want to execute a looping. For statement also for loop. Iterators is also one of the key element of looping. This one because Python they measure heavily in the collection of object. Sometimes you want to iterate the object. So one of the functionalities that Python is the application of iterators, so that you can iterate the object itself, the object of your data structure itself. Later we see the example of the application of iterators, simple application of iterators. The range and the exchange command, the list comprehension, the break statement, the Phyton statement. I think you are familiar already with all this. Most of this you might be familiar if you have done Matlab programming before. So this is the example of the if-else statement in Python. Okay, one of the things that you need to pay particular attention when you do Python programming is the indentation of your Python script or your Python program. Unlike C++, where you have to use the curly bracket, in Python they don't have any curly bracket, but you must make sure that you have to indent the subblock of the code. You must be in the sub-indentation. Example, in this case, this is the example of if-else statement. So anything inside the block of if statement here must be indented one step level inside it, because Python pay particular attention of your indentation. The indentation must be in the correct level. For example, this is all the sub level of the if-else statement must be indented in one indentation inside. Okay. Okay. Oh, the while statement. It's not the while statement. Okay, and then another loop statement with the iterator. So the example of loop statement with the iterator. Also, you can see any block of code inside the for looping must be indented one level inside. So this is the example of loop statement using the iterator. You have the iterator to iterate the list of this family list. So in this case, these siblings will store the value of all the elements in the list during the iteration. So in this case, you can just print the strings. It will show you the which current element that is being iterated. This is the example of loop statement with the application of iterator. Another example of application of loop statement is when you use the range function. So you can see this is the same functionality. They want to achieve the same functionality with this loop statement, where you want to print each of the element inside this family list. The only difference is that this one you use the iterators. Here you use the indexing, the list indexing. So the I here represent the index of your list. So here the index of your list is, and then you use the range command. Where the range command you give the length of your list. So to access the length of your list, you use the len function. So the len function, you supply the name of your list, will give you the length of the size of your list. And then you can use this loop statement where the I here is now represent the index. Index meaning 0, 1, 2, 3, and depending on how many elements inside your list that is accessed by this len element, len function. And also it achieves the same functionality with this previous loop statement. The only difference that is that this one you use iterator, this one you use the indexing. Okay, another function that another functionalities that you need to be aware when you do Python programming is the application, is the function. Sometimes you need to create a function that run a certain block of codes. In Python, to create function, you have to use the def keyword. And the function in Python can accept any number of arguments and can return any number of argument itself. So the example of Python function you says, let's say that you want to create a Python function to calculate the ODE of this system, and then the function itself will become the input for the ODE solver. So this is the example of how you do your how you manipulate, how you use the Python functionalities, Python function functionalities, and also the application of ODE solver, ordinary differential equation solver. So in this case, we're going to use the ODE solver from the SciPy library. So this solver we call the solve IDP, stand for solve initial value problem. And then, so in this case, like in Matlab, if you aware in Matlab, if you want to use the ODE 45 or ODE 115, you need to create a Matlab M-file function that accept the input, in this case the T and the ODE states, and then will calculate the derivative. Same here. So in Python, you need to provide this information in the Python function. And to create this Python function, you need to use the def keyword, stand for definition, function definition keyword. So you use the def, and then you provide the unique name of your function. And for this function, you need to have two input arguments. The first input argument represents the time, and the second input argument represents the vector of state of your system. So like in this example, you have two states represented by A and B. So the X itself will store the vector A and B. Okay, and then so this is the parameter of your model, the parameter of your ODE model. So the A itself is stored in the vector in the X0, and the B is stored in the X1. So okay, again, see, take note that in Python, every indexing must start with the index 0. Okay, unlike Matlab, where you start your indexing with the number 1, in Python, the indexing start with 0. So this is, so in this case, it has A and B to access the particular state. And then this is the derivative of A and B with respect to time, where they represent the model of your system. So in this case, you just code all the mathematical relationship. So this is the mathematical model. And then, so in this case, since in this problem you have two states, so you have the way that you return the state is by using the list. So in this case, you create a list, and the element of the list is the derivative of your ODE. It's represent the derivative value of your ODE. So this function return the list that store the element of your ODE model. So this is how one way you can create a function. And in fact, this is one way that you need to follow if you want to use the soft IDP function in the Python. So this is the function definition part. Okay, so the function definition part, you can see also within the function definition, you need to align your code properly. You have to indent your code properly. You must put one level of indentation inside the block of code. So once you type the return keyword, then the Python know that this is the end of function definition. So now you can, so this is the outside of the function definition where you create the t-span vector. So in this case, you want to solve the ODE from time 0 to time 5 with 100 point. So 100 here meaning the number of point from 0 to 5. So in this create the time span, the span of time. And then, so this is where you call the soft IVP function. And the soft IVP function, you supply with the function definition, supply with function that you have defined here. And then this is the list that represent the start time and the end time of the ODE integration. Okay, so this list represent the start time. So the start time is t-span 0. And the end time is the final element of the t-span. So in order to access the final element, you put the -1. This, if you aware in Matlab, if you want to access the end element of your vector, you use the end keyword. In Python, if you want to access the final element, you use the -1 to access the final element of your array, of your list. And then the list here represent the initial condition. So in this case, we're going to start initial condition for 1 and 0s. 1 is for the initial condition for the first state, which is our A, and 0 point is the initial condition for our second state, which is B. And then this t-eval, okay, this t-span that you created, you can pass as additional argument to your soft IVP function. So in this case, the t-eval is what we call the keyword argument. This keyword argument is if you want to supply additional argument to your Python function. This keyword argument is sometimes we call the optional argument. If you don't supply this optional argument, it's also okay. But in this case, they will just supply the result of your integration at the first time and the end time. But since you want to evaluate all the time point from 0 to 5 here, so in this case, you can supply another additional argument, additional keyword argument, where you supply the vector that you created as the additional argument. So in this case, the solution that will be generated for you will give you the solution at all the point inside your time t-span. So this is how you call the function and supply all the required argument. So now, once you solve it, then you can access the profile. So this A-prof represents the profile for the A state and the profile for the B concentration. We can say this A and B concentration. So this solve is just a structure where if you want to access the particular variable inside the structure, you can use the dot symbol. So inside the sol, you have the dot symbol. So the first, you can see in this way, you access the first row of your solution vector. So the first row of your solution vector represents the profile for your A variable. And the second row of your solution vector represents the profile of your B variable. And then you can, if you want to plot, then you need to import the matplotlib function, and then you can plot your result. So in this case, here we see the application of Python function and also additional application of Python scientific libraries. For example, here we use the scientific Python library. We call the integration function as presented by the solve IDP command. And here you can see another way that you can import that particular function. So once you run this particular import keyword, then you can just straight away call the function by supplying this function name in your codings, in your Python code. Okay, so far any question? Have you all able to download the slide that I provided? Okay. Anyone here already install your Anaconda distribution? Anyone already install your Anaconda distribution? I want to know if anyone already successfully install your Anaconda distribution. If you're able to install your Anaconda distribution, you can launch your Spider, and you can try to practice with several of the examples that I show just now. Okay, so far any question that you want to ask before I proceed with the final, I can consider a final part of my presentation. So I want to know, anyone able to install your Anaconda distribution? Anyone have any problems? So I assume that during my presentation, you already tried to install your Anaconda distribution into your machine, and you try to open the Spider IDE and try to familiarize yourself with the. I think for those of you who have done a lot of Matlab programming, it's not a culture shock for you when you open Spider. It's because the feeling is there, because I think the people who created the Spider, they try to incorporate as much as possible the Matlab feeling into it, so that you don't encounter any culture shock issue when you want to do your Python programming. Okay. So I want to proceed with the final part of my presentation. So in this case, here I want to show example of how you can apply Python to do machine learning. So in this case, I want to show some very preliminary example of machine learning where you want to try to feed a distillation tower data using neural network method. And this neural network method can be accessed once you install the scikit-learn library. So if you already install your Anaconda distribution, you just no need to concern about this, because this scikit-learn library is already provided in your default installation. So I think it's possible if you can download this towerdata.csv file in your machine. So that's why I hope that by now you already have successfully installed your Anaconda distribution, and you can launch your Spider IDE, because this one we're going to do some kind of hands-on with it. So if you're able to download this towerdata.csv file, you can open. I'm not sure. I think you're already familiar with this distillation tower data. For those of you who do research into machine learning or manual regression, I think I'm already familiar with this tower data. So if you're already familiar, it's good for you. So in this case, I just want to show the example of how you can run neural network in Python in order to feed this vapor pressure data to your distillation tower process conditions. Okay, so for example, if I want to open this CSV file, you can see this can see in this tower data they have several reading from the particular sensor. Okay, you can see the sensor tagging is already provided as the first header here. Here, I want to feed my neural network model to predict the vapor pressure based on the sensor reading, based on the process condition as stipulated by this sensor reading. So in this case, so all this is my input, and the final column here will be my output, my neural network output. So this is how the example of how you can, a very basic example of how you can run the neural network regression and prediction inside Python. So in this case, you can see I run inside the Spider IDE, and you can see I use the NumPy library as to extract my data from my tower data.csv. Okay. I think later I can open this session to any discussion. Here I just present how you can the workflow of how you can train your machine learning model, neural network model, based on the data that you provided. So in order to get my data, in order to import my data, so in this case I use the gen from txt function that is provided as part of NumPy library. So I supply my file name, okay, and then I supply the delimiters because this is the comma separated value file. So I need to supply the comma delimiter in order to distinguish between one data to the next in the particular row. And then I supply another keyword argument to skip header, meaning in this case I want to just get the values without the header. So in this case, so in order to do that, I supply integer 1, the value of 1, meaning I want to skip one header. So skip header equals to 1, meaning it will ignore the first row of your data file. If you give skip header equal to 2, then it will ignore the topmost row of your data file. So in this case, because I want to ignore, my header is in the topmost row, so I just supply 1 as the skip header keyword argument. And then, so in this case, my Y output will be the final column data. So in this case, instead of using the n keyword in Matlab, so in order to find the final column data, the data will be from my final column. So I use -1. So when Phyton see -1, they know that I specifically mentioned that data will come from the final column. And this column operator, I think you already familiar, is representing data slicing. I think if you do Matlab programming where you manipulate matrix, you are already familiar with this application of data slicing using the colon operator. Okay, and then for the X input, okay, so for the X input, I select all the column, and then I want to select all the data without the final column. So this is how you specify. So in this case, also using the slicing function of the colon, and then I put here -1. Even though logically you think if I put -1, then the Matlab will still take the final column data, but since in Python they will ignore the numbers that is specified here, meaning that they will ignore the final column element. The final column data will be ignored because this is one of the issues when you are doing programming that start from 0 index versus doing your Matlab programming where you start everything with index 1. So this is the consequence of changing the index from 0 to 1. Okay, and then I want to pre-process my data. In this case, I want to scale my input data so that it will have standard deviation, mean zero and standard deviation 1, in order to make sure that my neural network training will be well behaved. So in this case, I use the sklearn. This sklearn is the scikit-learn library that I mentioned. Okay, so in the Python they call it sklearn, the short form for scikit-learn library. So in this case, the sklearn, I import the pre-processing module, and then this pre-processing module I call the standard scaler, and then I supply my input data in order to create a scalar object. So the scalar object will store the information about my input data, so that if I want to create a scale input, then I call this scalar and call the transform function. Then I supply the data input, so that the scale here will represent my scale input data. So now I can call my neural network function, where here they call it as the MLP regressor, multi-layer perceptron regressor. And then also I call the train test split function in order to split my data into the train and test collection. Also this one is already provided as part of the scikit-learn library. So then I call this train test split function in order to split my data into the train data and test data. Okay, now I can start to train my neural network by calling the NLP regress object. I supply my training parameter. Okay, this random state is just for the reproduction purpose, because due to the nature of random initialization of your neural network weight, in order to make sure that you can reproduce your neural network training. So in this case, you can supply the random states keyword. In this case, you supply 1. So in this case, whenever you use the same value here, you can reproduce your neural network training result. Okay, this is the maximum iteration. I set 1000 as my maximum iteration. So this is the input, the neural network training parameter input, and then I call another function within this MLP regress object, where this function is called the fit function, and then I supply the training input and the target output of my training data. So in this case, run. So you can see they mentioned this warning because my iteration reached the maximum iteration, but still it's not converged. But in this case, I just ignore it. So now I can run so now my neural network training result is stored in this regressor object, this REGR object. This REGR object. So whenever I want to use my neural network to do the prediction, so I can just use this REGR object and call the predict function within this object, and I supply the new data to my neural network so that it can make a new prediction. And then, so in this case, this part is for the analyst validation purpose. For the performance validation purpose, I want to check the Pearson correlation coefficient of my neural network prediction using the test data. You can see the Pearson coefficient is not good. It's just 0.716. So meaning that we can think a lot can be done in order to improve it further, but that's not my concern here. And then I also can plot. You can run several plots. For example, I want to test the scatter plot between my prediction and my test data. So I use the Matlab library. So this is the example of the neural network prediction versus the test data. I plot in the scatter plot. As you can see, the result is not that good. You can see there's a wide scatter of the prediction versus the test data. And in fact, the Pearson correlation coefficient is only 0.716. But the point here, I just want to illustrate how you can do machine learning. In particular here, in this example, I use the neural network that I can access through my scikit-learn library in order to do the data fitting, which I think you are familiar if you already done a lot, if you have done some kind of neural network training in your Matlab. So here to show that in Python also you can do these things, okay, in the Python programming, especially if you use the Python IDE, then you can do this in the environment that feels like a Matlab. I think that's it for my presentation. So any question so far? And I really hope that if you're able to install the Anaconda distribution and you can practice some of it during the session, just to get a certain feeling about. In my opinion, in terms of comparison between Matlab and Python, I think Python is also quite competitive. They have many functionalities that is comparable with Matlab. And the most important thing is in Python, all these libraries is mostly open source, meaning that you don't have to pay in order to using it. So there's no concern about whether you want to use pirated version of the library. There's no such thing because so this can give you, and then you can, because most of these libraries are open source, then you can peer into the codings. If you want to learn, if you want to go into more detail about the codings, you can. Also, you can inspect their coding in more detail. That's one of the advantage of using Python, because they are mostly open source. Unlike Matlab, they are proprietary. And then, so if you want to have additional modification, you have to wait until they release a new version of your Matlab, okay, before your wishful modification is incorporated. But in Python, because they are supported by a strong ecosystem of developers who are volunteering in the project. So in this case, you can bet that the pace of development is quite fast if compared with the Matlab. And of course, you can learn a lot of programming. And because Python is a general purpose programming language, okay, so in this case, you can use Python to do web-based programming, to do the desktop-based programming. So in this case, you don't have to be shackled by the requirement that if you want to do Matlab programming, you have to install the Matlab engine first. So this is one of the advantage of Python programming. So, okay, any question that you want to ask? So I want to know, any one of you able to install the Anaconda distribution in your machine? Have you able to successfully install it? Anyone, encounter any issues, difficulty? And this slide also I already provided together with this tower data. I think you can access in the Facebook. If I remember correctly, Fauzi already mentioned that you can already access this presentation slide, and this particular tower data in the Facebook page of your My Process Control Society. Okay. So any question? So Fauzi, what's next?
All right. Thank you for the presentation. Okay, any question if you like to ask, you can just unmute your mic, or if you can text in the chat room. So Nazri and I, we can read and your question and Nazri try to answer. Okay, so if you have any question, we can take one or two question before we end of this session. Okay. So Nazri, I would like to ask, yeah. So I mean, you have experience in Matlab and Python.
Yeah.
Okay, how about
Yes.
when we want to deliver the code? I mean, the outcome or the product to the end user. So which one is much more convenient, Matlab or Python?
In my opinion, much more convenient if you use Python. In fact, in Python you can create an executable file by using this package that we call PyInstaller. Meaning, if you code your program in Python and you want to give the program to your end user without your end user need to compile it in their own machine, then you can use this Python library that we call PyInstaller in order to create an executable file for your program, so that the user can just click the executable file. You can just give the program to your user in the form of executable program, and the user can just execute it in their machine without doing any kind of additional manual installation or whatever. In fact, of course, if you want to make it more systematic, then you can also create a installer, a window-based installer based on the executable file that you generated from your Python file. But that one is requires user who are familiar with the, because that skill requires the people who are familiar with the high level stuff of Python programming. I think for the user who are really into this Python programming, then they can explore that opportunity. So the point is, yes, I think in Python is much more easier if you want to share your coding to your user. Plus, if your user already familiar with some kind of Python programming, for example, like I mentioned here, you can just simply install the Anaconda distribution inside your machine, and and then you just can give the Python file to your user, and maybe just give some kind of instruction of how to run the program, and user can run it using their own machine, because the user don't have to worry about have to install MATLAB, have to obtain another copy of MATLAB, meaning that the user have to scramble in or to buy MATLAB. So the user doesn't have to face with this kind of situation, because here the user can just download whatever distribution that they prefer. For example, here I use the Anaconda distribution, and then you just give the coding to your user, then user can run it in your own machine without any issue about any concern about whether they have to deal with the pirated software or whatever. You getting that stuff? Okay.
Okay.
All right.
Thank you. Okay. A good answer. All right. Okay. Any question? Maybe you have your from previous, or you have uh, code, or maybe similar. Maybe you think you want to use Python for your project or for your assignment or for your study. You can. I think you can talk to Nazri, or I think Nazri, you can provide the contact email at the chat room, so that
I think
maybe
you can contact Fauzi also can.
okay, maybe you can contact the my PCS. Yes, no worry for that. Okay.
How is
There's
it convert the
one
codes
question.
from Matlab to Phyton? I'm not
Yeah.
okay. I don't know, but this one, I feel, yeah, because for my thinking, yeah, this is one of the good question. Because for me, if you ask me traditionally, you have to convert it manually one by one. You have to convert it manually. But I'm not sure if there is already exists a library or package out there that can do this automatic conversion or not. Maybe if you want to, you can try to Google it. Maybe because you know lah, when talking about open source development, somehow in another part of the world, people have already done it for you. Already, because the same people have also encountered this question, and they also have tried to create their own version of the package that try to solve the same problem. Because if you ask me, of course, I would say, okay, you have to convert it manually, meaning that you have to open your MATLAB script and then you have to do it manually. But I bet maybe people out there already have create some kind of automatic conversion tool that try to take care of if you want to convert from Matlab to Python. Because we're talking about open source, the possibility is very wide ranging. Maybe people already implement this solution out there. Who knows?
Yeah, Nazri, I just Google it. Yeah, there's since 2018.
Okay.
No, not 2018. 8 years ago, the
Oh,
thread has been published in the Stack Overflow, and
okay.
then they close the answers. You can
Okay.
use PyMatlab,
Oh,
PyMatlab
yeah.
to
Okay.
convert.
Yes.
You use PyMat2. Actually, there's many a module that we can convert directly.
Okay.
But not
Yeah. Yeah.
sure, maybe because some of the code from Matlab or library from Matlab, maybe they upgrade, then you might not have a swift conversion.
Okay. Yeah.
Yeah,
Yeah.
yeah.
Thank you. Yes. That's why like Fauzi mentioned, one of the your reference website is Stack Overflow website. There's a very comprehensive reference. If you want to do Python programming, if you encounter difficulty, then you can just refer to that Stack Overflow website. And definitely the same people with the same problem has already asked, and other people already provided the solution there. So yeah. Because from my experience, when I start my Python, I didn't face with the issue I want to convert MATLAB because I really start from scratch. So, but for some people who want to convert, who have already done a lot of MATLAB programming and you want to convert it to Python, I think you can search the Google because I think the solution is already out there. And like for Mr. Fauzi mentioned, okay, if you can see in the link that is provided in the chat, you can go to the link and you can follow the discussion there in order to get into more detail about this issue, about this situation.
Okay. Now can you see my screen? Junaidi? Can see
Yes,
screen
yes,
or not? Can
yes,
see
yes.
this? Okay, good. So we have a few series of webinar for March and April. Okay, for Phyton series webinar, we have for next month, 14 April, Phyton for process control engineering. So I will be a speaker for that session on the 14th next week, Wednesday. Same time, 3 to 5 p.m. And then another one we will have next week. We have Professor Thomas Emerlin from Manchester University, Canada. So he will be talking about the topic on process control education in era of Industrial 4.0. So please, if you like to join the seminar, right, the webinar Thomas from Professor Thomas, please register through our webinar QR code here. All right, and then if you have any if you have any question or if you have any inquiry regarding to this talk, please drop an email to webinar@mypcs.com. All right, and then after the following week, we have another person, another professor from New South Wales, Australia, Professor Jibao. He's an associate editor of Journal of Process Control. He'll be talking about the distributed model predictive control. It's 29 March, Monday. So please note at the time at the poster, and more information will be posted in our Facebook. Please go through there and you will see all the information related to the webinar series. All right, and then we have Professor Sigurd Sogestad, and then the last one will be Professor Manu Kano. Yeah, so all this will be happening in March and April. Okay, thank you for attending this session. All right, all the best and stay safe. Take care and goodbye.